If you want to become a network engineer and get your CCNA, you got to know what VLANs are and how to configure them. And in this video, we're going to do just that. We're going to go ahead and explain what VLANs are and how they work. From there, we'll go ahead and actually configure VLANs on some switches and actually trunk them across switches so that we can have our VLANs span across multiple switches. We'll configure access ports so that we can actually connect up some of our PCs, and we'll even add some additional PCs and devices and put them in other VLANs to show how we can actually segment traffic and block VLANs from talking to other VLANs if we choose to. And I'll even show you some troubleshooting commands that you might want to know for when you're studying your CCNA, and more importantly, the real world when you run into issues related to VLANs and start to realize that you picked the wrong career field. And don't worry if you know some of the stuff already, I'll leave timestamps below so that you can hop around as you need to. Anyways, enough talking, let's go ahead and get into the video. So what are VLANs? VLANs are virtual local area networks, and it's essentially a technology that allows you to take one physical switch or a whole bunch of switches and carve up their ports into logical networks, each VLAN acting as its own completely separate network, even though those VLANs are running on the same switch or switches. And we'll plug computers into each of those different ports which are assigned to those VLANs. From there, we'll assign a network to those VLANs, which the computers will obviously have an IP address in, and those computers will be able to talk to each other within their own VLAN. However, by default, they won't be able to talk to other computers and other VLANs unless we set up routing and have an actual router which manages the routing between the different VLANs in their networks. And now this is great because we can segregate network traffic so that our Windows computers aren't actually seeing any of the traffic related to, let's say, Mac computers that we also have on the network. We're sick and tired of seeing those guys with their little blue bubbles thinking they're better than everybody. So we don't want to see that traffic. We can keep the Windows guys in VLAN 1 and the Mac guys in VLAN 2. Also, a quick CCNA tip you might want to know is the fact that VLANs actually help you to isolate broadcast domains. And if you don't know what a broadcast domain is, essentially picture your network as a big open office. Each computer on the network is like a person sitting at a desk. When someone needs a piece of information, like potentially where the address of client 1 is, if he doesn't know, he'll just go ahead and scream it out across the entire office, meaning everyone in that office, even people who might not be related to HR and know that information or even care about it, will also receive that. Now, imagine multiplying that by thousands of computers on the network or people in the office. Everybody's shouting all the time, receiving information that they don't need and consuming bandwidth. Well, we can isolate these PCs into their own VLANs so that they're not shouting to everybody. Only people, or in this case, systems on that same VLAN are actually receiving that information, and we're reducing the amount of unnecessary broadcasts being sent to systems across our entire enterprise. And another tip you want to know is that we have VLAN IDs ranging from 1 to 4094, and by default in Cisco devices, VLAN 1 is the default VLAN unless you change it. All right, so let's actually go ahead and jump into the lab and start configuring our VLANs. So I'm actually logged into my Eve lab over here, and we've got a little diagram of how our network is set up. So we've got 3 access layer switches. Those are these switches down here, right? These are going to be the switches that we actually connect end devices to, like our computers, our printers, stuff like that. And then we have a distributed switch up here. These are the type of switches essentially which we are connecting all of our access switches to. It's going to be kind of like a centralized switch. Obviously you can have multiple of these, but in this case we only have one. And then that distributed switch actually connects us up to our router here. Now this router is going to be the device that actually manages the routing between our different VLANs, and we have a few different VLANs. We've got VLAN 10 for our basic users, 20 for VoIP, which are like our IP phones, 30 for management, and 40 for our printers. Now, obviously, we're not going to use all these VLANs in this lab. We're just going to be using 10 and 30 for the most part. So let's go ahead and do that. We're going to create all these VLANs, and then we're going to assign PC 1 and 3 to VLAN 10, and then we'll go ahead and assign PC 2 to VLAN 30. And what we're going to do is span the VLANs across all the switches and test inner communication within our VLANs. So testing PC1 and ensuring it can reach PC3. And then we'll go ahead and then tag our VLANs up to this router here so that it can actually manage routing between VLAN 10 over to VLAN 30, which is where this PC is going to be at. And I'll also show you just quickly how we can actually segment traffic so we can stop VLAN 10 from talking to VLAN 30 completely. And you'll see why we want VLANs, because we can segment via security. But anyways, let's go ahead and hop over to the CLI for our switches. As you can see here, I'm actually logged into all 3 access switches already, and I'm just using a tool called Secure CRT. I like using this because I can actually manage all the devices at the same time. So let's just go ahead and look to see what VLANs we have. So I'm already logged in. You should be logged in too. So I'll go ahead and run a show VLAN. And we can see here, we only have one VLAN currently, which is VLAN 1, and that's the default on all this. So we're going to go ahead and create some. So we're going to do configure terminal, and hit enter, and then we'll go ahead and just make it very, very simple. VLAN 10, enter, and then we'll give it a name, and this will be basic users. And that's it. That's all we got to do. I appreciate you guys' support, and I'll see you in the next one. Peace. No, I'm just kidding. That's just the first step. All right, so now we've got a VLAN created. We'll go ahead and exit out of that, and then we'll go into VLAN 20. and that'll be name VoIP. Then we'll switch over. We don't actually have to do exit. We can just go VLAN 30 straight from the other VLAN, and it'll put us into VLAN 30 configuration mode. And we'll put in name management. And then we'll do that for VLAN 40 as well. VLAN 40. So one thing I did want to note, yes, you think at this point we would have created our VLAN 40, right? Because we're already in the configuration mode. But if we actually do a do show VLAN, you'll see that VLAN 40 isn't actually there yet. VLAN 40 won't populate until you actually exit out of the VLAN configuration mode. So we'll do name printers, and then we'll exit. And now if we do a do show VLAN, you can see we've got VLAN 10 through 40 here. So that's creating the VLANs. Now we need to actually assign these VLANs to ports. We need to set up a trunk port. So we'll go ahead and do that. So you can see here on all the access switch ports, connect to the distributed switch via gigabit interface 00. It's the same on all of them. So what I will do, I'm gonna do end. So back in here, I'll go back into configuration mode, config T. Then I will do interface gigabit 0/0. We'll do a no shut so we can bring that port up. And then we will do switch port trunk encapsulation.1q. This is essentially letting them know the interface that we're going to be using 802.1q, which is for VLAN tagging. And then we will do switch port mode trunk, which is saying that this port is going to be a trunk. We're going to be tagging all the VLANs across it so that each of the switches knows that we will be tagging all the traffic across this interface. And it just won't be an access port, which is an untagged VLAN. So now that we've got the actual interfaces all set up here, from here, we would have to go to the distributed switch and ensure that gigabit interface 0, 1, 2, and 3 is also set up the same way. Now in this case, I've actually already done that. If I actually go into distributed switch 1 and log in, okay, and I do a show run interface GI 0/1, 2, and 3, we can see here that they're already all set up. I've got a description on there just knowing which one is going to which. We have encapsulation.1q, switch port mode trunk, and they are already up. So we're already tagging across. So essentially we've set up the tagging down from the distributed switch and up from each of the access switches, meaning VLANs are now being tagged across. Now, when you are setting up your tagging for switches, you can, let me get rid of this. You can actually specify which VLANs you want to go across an interface. If you want to restrict the amount of VLANs that are crossing an interface, we are still in the configuration mode for this trunk interface here for 00 on each of our access switches. We could, instead of just doing switch, we could do switch port trunk allowed VLAN, and then you just specify your VLANs at that point. You can say all for all of the VLANs, which is also just the default. From here, you just do the range. So let's say 10, 20, 30, 40. And now if we look at do show run interface GI 0/0, look at the running configuration, you can see we're actually only going to be tagging 10, 20, and 30, and 40 as opposed to anything that's created. Switch port mode trunk, it's going to allow all VLANs. And looking at the running configuration of the interface just shows what we've configured to allow across the interface. To actually see what the switch is actually tagging, because there could be reasons why it's not tagging a VLAN across an interface, you'll want to actually run this command to verify that it is tagging. So do, we're putting do because obviously we're in configuration mode. If we weren't, we could just do show, but do show interface trunk. And you can see here we've got interface GI 0/0. These are the VLANs that are currently allowed across it based off of our configuration. And these are the ones that are actually active across the interface 1040 and not being pruned by spanning tree. So you can see we do actually have all the VLANs being tagged across our trunk interface. Okay, so now that we've got our VLANs being trunked between our switches, so we've created all the VLANs across all of the switches, and we are trunking them up to our distributed switch and down from our distributed switch to our access switches. We need to go ahead and assign these PC computers to the VLANs that they're going to be assigned to. So we're going to go ahead and go into switch 1 and 3, and we are going to assign them to VLAN 10, and then we're going to go into switch 2 and assign it to VLAN 30. Now I'm going to be able to configure all three of these at the same time because I'm in secure CRT, and be aware that each of my switches I'm using gig 0/1 to connect to the end PCs. So I will exit out of the trunk mode, and then I'll go into interface GI 0/1, and I will do switch port mode access, and then switch port access VLAN. And for switch 1 and 3, I'm going to do 10 because those pieces are going to be assigned to 10. But for switch 2, I'm going to put this one in VLAN 30. And then I will do enter. And this essentially is just making this port an access port. So we're not going to be tagging the VLAN across it. We're just assigning the interface to it. And then we're going to do no shut to bring those ports up. So now each of these PCs are in their respective VLANs. Now, obviously you have to assign these PCs an IP address, or you could use DHCP and all that stuff, but we're not going to get into it. Just be aware that I've already assigned each of these PCs their own IPs, and these are what they are. And just so we're aware, VLAN 10 is assigned this network, 10.222.10.0, and VLAN 30 is 10.222.30.0. And of course, each of the PCs have an IP within that range for the networks. So let's go ahead and actually look at the IPs for these PCs, just to confirm that they are actually all set up with the correct IPs. So I'll scroll into this, scroll into this, scroll into this, and I'll do show. And we can see here PC 1 has the IP address of 10.222.10.2, which is correct. PC 3 is 10.222.10.3, which is correct. And then PC 2 is assigned 10.222.30.2. Okay, so theoretically, without even having any routing set up, as long as our trunking is all set up correctly and VLANs are assigned appropriately, PC 1 should be able to ping PC 3 at this point. So let's go ahead and try that. So from PC 1, I will do ping 10.222.10.3. And you can see we are getting a reply, and which means we do have that connectivity. Now, just because we can go ahead and do it the other way, although we already know at this point it would work, is ping 10.222.10.2. Yep, so it looks like ping works both ways. Okay, now let's see if we can actually get PC 3 or 1 to ping PC 2, which is in a whole different VLAN and we don't have routing set up. Ping 10.222.30.2. Timeouts. We're not actually... Oh, damn.
You are so dumb. You are really dumb. For real.
Future Keith here. Yeah, I'm an idiot, and let me explain myself. So technically that ping test between VLAN 10 and 30 did and didn't work. It did work in the fact that we had trunking and routing already configured up to the router, which is why we got a prohibited message, but it didn't work. Obviously, we got a prohibited message because I actually had an access control list applied to the interface. So even though the traffic got all the way up to the router from VLAN 10, it didn't actually go from VLAN 10 to VLAN 30 and down to the PC because of that ACL. I'm going to go ahead and explain that now. So technically it shouldn't have worked based off of the fact that we hadn't configured it while I was recording, but it kind of did work because I had already had it set up. Anyways, so it looks like we actually can. It's because prior to this video, I actually set up the trunking all the way up to the router already and enabled the interface. Okay, this shouldn't have worked because theoretically while you guys were watching, I hadn't set it up. But let's go ahead and look at the distributed switch, right? So the distributed switch here, it has a connection up to this router on GI 0/0. So if I do a show run interface GI 0/0, we can see it is a trunk port, which is what it needs to be because we're doing a router on a stick configuration, meaning we're tagging all of our VLANs up to the router, and the router is essentially accepting those tags and routing across because it has IPs already assigned to each of the VLAN interfaces. So we are trunking up to it, meaning we're putting our access ports to these PCs, we're trunking it up to the switch, and the distributed switch is actually trunking it up to the router. So traffic is flowing from PC1 on VLAN 10 up here, and then it goes to the router, and then the router decides whether or not it will route it down to PC3. In this case, it won't, and there's a reason for that. But before I go into that, let's look at the router configuration. We're not going to show you how to configure it in this video. That's out of the scope of it. But if we log in and we look at the running configuration for this interface, which is connected to the switch here, we can see nothing. Sorry, am I even looking at the right interface? Yes, I am. Okay, so I had to create sub interfaces because I'm doing a router on a stick configuration. So if I do a show IP interface brief, we can see here that each of my sub interfaces are already set up on this router. So the sub interface for VLAN 10 is assigned this IP, meaning this is going to be the default gateway that the PCs send its traffic to if it's for traffic that's destined outside of the VLAN. And we actually have VLAN 30 set up here as well. We've got all of them set up. So essentially the router is going to take any traffic it receives on VLAN 10 and send it to its interface on VLAN 30, which would then send it down to the device that's on the VLAN 30. So in this case, he sends a ping out, it goes up to the router, and then the router sends it down to this PC on the correct VLAN. Now, the reason the ping actually failed is because I actually set up an access list, which is essentially a list of traffic that's allowed across specific interfaces. And I did this so we can show how we can actually segment traffic and stop a VLAN from talking to another VLAN. So if we look at the interface configuration for interface GI 1.10, you can see we have this access list on here, right? IP access group 100 in, and this is an access. If we look at the access list for 100, show IP access list 100, you can see here I'm just denying anything on the VLAN 10 network over to the VLAN 30 network, which is why it actually stopped that ping. You see here, I've got 4 matches. So if I were to test again, right, try and test it again, you're gonna see here that this will actually increment. See, now I've got 8 matches that were blocked. So if I actually take that off, right, 1.10, no IP access group 100 in, and then I attempt to ping again, you'll see that I'm actually able to ping from VLAN 10's PC up to the router. The router does the routing between the VLANs, and then down to PC 30, and we can hit PC 2 now. So that's the great thing about VLANs, is we can segment our VLANs, we can establish routing. However, we can put things in between the path of our VLANs so that we can actually stop things from talking to each other if we needed that segmentation. Now, that's basically it. We've configured VLANs on all of our switches. We trunked our VLANs between our switches. Then we also assigned each of our PCs to access VLANs. We gave them IPs, and we tested pinging inter-VLAN communication between PC 1 and 3 on VLAN 10, and then inter-VLAN communication by adding a router in the mix and attempting to ping between VLAN 10, PC 1, to VLAN 30, PC 2. And we identified how we can actually segment the traffic so they can't talk as well by utilizing an access list. Now you can do all kinds of things. You can actually insert a firewall. There's a lot of different methods you can use, but that's just a quick overview of how VLANs work on the network. Now, some quick tips I wanted to mention. I did mention native VLANs earlier. And if you actually go back into our switch configuration, I'll just get rid of some of these real quick. So if you look at the trunk interfaces, show interface trunk, you will see here that this is the distributed switch and these are our access switches. So gig 0/0 on all of our access switches, they are tagging each of these VLANs across the trunk. And the same can be said for the trunk interfaces on our distributed switch. It is allowing VLANs 10, 20, 30, 40 currently. So if you actually look at the output from our show interface trunk command, you can see here that we have a native VLAN, and that's essentially our VLAN that's not going to be tagged across these trunk interfaces. Now you can actually switch that if you would like to, and if you do, you want to make sure that it's the same across each of your trunk links between switches, because if not, let's say the native VLAN is 10 over here, but it's 1 here. When I send that traffic that's dedicated for VLAN 10, it will be sent across untagged here. However, when he receives it, he's going to think it's my native VLAN, it's untagged, so I'm going to put it on VLAN 1, essentially, right? Which means that now this PC theoretically has access to any devices that are on VLAN 1. And if we assign it an IP within the VLAN 1 range, which we don't have here, but if we did, it could theoretically talk to other devices. And this is called VLAN hopping. This can be an actual security concern. So you'll want to make sure you have that the same across the board. And if you do want to switch it, you can actually go into the interfaces for the trunks, right? Config T, and then you would go into the configuration for those trunk interfaces, and then you would just do switch port trunk native VLAN, and you can assign whatever you want. In this case, I'll do 10, but for the distributed switch, I want to put it to actually just be 1. I'll leave it as 1. And I wanted to show you something here. So if you do that, now we're good to go. We've got them all switched. You will notice you'll start to get these errors from your switches saying that the native VLAN is different. You see on here it's 10, however on the other side it's 1. So the switches are going to tell you that you have a native VLAN mismatch, and that's something you want to obviously address by going into the switch that is incorrect, interface range GI 0/1 through 3, and I'll just do switch port trunk native VLAN 10. And there we go. Now native VLAN 10 is going to be the same across each of the different switches, and we are good to go. So if I do a show interface trunk again, we will see that the native VLAN for each of our interfaces is the same, 10. Now the interface for this one is going to be different, and that's because this is going up to the router. I'm just going to keep that as 1 right now because I'm tagging from the router down on each of these. And you can see here that spanning tree is no longer blocking VLAN 10 and 1 across each of the interfaces because we have a correct VLAN match. Speaking of spanning tree, if you ever know for sure that you do have your interfaces trunking the correct VLANs, however, for some reason a PC just isn't going between other VLANs up to your router or whatever, you might want to verify that spanning tree isn't actually pruning the VLAN, meaning let's say we have VLAN 1 here and she's sending traffic up. If this switch is pruning any traffic from VLAN 1 because of a native mismatch or whatever it is, that traffic will never actually make it where it needs to go because he's not going to be listening for any traffic on that VLAN because he's pruning it. And to confirm that he isn't pruning it, you would just use that same interface command, show interface trunk. And here it'll show you which ones are not being pruned. However, if you want to look at a specific VLAN, you can do show spanning tree VLAN 10. And this will show us here that VLAN 10 is whether it's a designated port or a root port and whether or not it's being blocked. If you ever see a BLK on a specific interface, that means that VLAN is actually not being allowed across the interface, is being blocked. And this will show you essentially the details for whether or not spanning tree is blocking specific ports from receiving any 802.1q packets or BPDU packets for spanning tree. I'm not going to go into crazy detail what it is, but this is just another way to see what spanning tree is blocking specifically for your VLANs. But anyways, guys, that is our ultimate VLAN guide. I really hope this was helpful. If you are interested and you want to know how we set up sub interfaces as well as SVI so that you can configure the actual internal routing on a router or a switch, so that you can get traffic running between each of these VLANs, that'll be my next video. But for now, that's it. I appreciate you guys' support. Definitely subscribe if you want to learn more about Cisco routing and networking, as well as home labs and tech how-tos and reviews and all that kind of good stuff. I appreciate your support, and I'll see you in the next one. Peace.